So the first question was maximize distance to the closest person. So you are given seats as an array. So 1 means that a person is sitting there already. 0 means the seat is blank, and you are planning to sit to a position so that you have enough space towards your left and right. Basically, most comfortable position. So how would you do that? And you can check the boundary conditions that seat length is maximum 20,000. That's it. So anybody has any question on the problem, first of all? In this example, this means like 1 means this seat is taken. These 3 seats are these 3 are blank. This is taken, this is taken, this is taken. So most likely you would prefer to sit on this one so that you have, one place blank towards your left, one place blank towards your right. If you choose any other seat, you will not get a better solution. Anybody try to solve it?
Yes, I have tried to solve it.
Okay.
So
Yeah, go ahead. What was your approach?
So basically, seems like there could be 3 combinations. One would be, uh, you can place someone in the start or at the end. If the first seat is available, then we can place at the start. Or if the last seat is available, then we can place at the end or somewhere in the middle. So that are the 3 options, because they told like there would be always one person inside.
Okay, so let's take some example here. So 1 0 0 1, and what is the, can you someone tell me what the first example was after this? 1 0 0 1, and then we will take that example to work on this. Or let me take a look. 1 0 0 1 and then 0 1. Okay.
1
0 0 1 and then 0 1. Okay. So how would you go about solving this?
So one thing is like, so basically, I will do a first one previous check, like how many, where is the first position of 1 from the start. So that will tell me if I put 0, if 0 is the first place, and if I put someone at the start, what would be the distance? That would give me the first max distance.
Okay, so in this particular case, the leftmost is 1. What will you do with that?
So I will. So in this case, so this one will be my starting point. Then I look for another one. Then once I get, so I will have so it's like a 2-pointer. I will have a previous and the current, where is the 1. Then I'll take a half of that. That will give me the max distance.
Okay. So, okay, I think we will go through that solution, hopefully soon. Anyone has any other idea? Or maybe I would say this is a very good solution, by the way. Any other easier idea?
Simple brute force will be try to place the 1 at every 0 wherever we have 0 there.
Can you speak loudly? I can't hear you properly. Hello? I can't see your name, but please speak loudly.
Yeah, is it better now?
Yeah, it's much better.
Yeah. So what I thought, I mean, after seeing this question is simple brute force will be like placing 1 at every 0, whatever I encountered, and a
Okay.
simple method which can tell me what is the distance of other one from this, the minimum distance of one from this. It will be n square, I believe, because I need to go for each 0 and uh, check the distance of one from that, the minimum distance of one from that.
Okay. Yeah.
Yeah,
Yeah. That is one brute force approach.
yeah,
O of n square will work for sure.
yeah,
And I think given that like what was the range 20,000, probably it may not be accepted, by the way.
yeah. Yeah, I think pre-computation in this case should be something helpful, which is like having some extra space and having that information
Mm-hmm.
can help me. I'm thinking more.
So at any point of time, what you are interested in, like when suppose I'm selecting ith position, for example.
Yeah,
So what I want to get the information that, hey, towards my left, what is the, first guy who is sitting towards my left?
yeah,
Same thing. What is the rightmost distance for the first person, like, so in this particular case, you have a person sitting here towards right, towards left, this is the person, right?
yep,
So towards left, you can say the value is 3, towards right, the value is 1. And you have to choose min of that, right?
yeah.
Because you want to maximize the distance towards both the side.
Yep.
So you will
One will
say,
come.
yeah, 1. So if you can do the same thing for all the I, you can get the solution pretty easily.
Yeah, but in this case, I have previous information, like the first index I have because I already traversed that, but the 3 is sitting there, is not there. So I need some information before even starting traversing this array.
Right. So what we are trying to reach to O of n solution, right?
Yeah,
And suppose the question was, forget about the right side. I just want to find uh, what is the leftmost guy to, if I am at ith index, who is the leftmost guy? Can I do one scan to figure that out?
yep, that we can do.
That we can do.
Yeah.
Now, if my question is, who is the rightmost guy towards myself? Can we do that in O of n?
We need to start from the end.
Sure.
Then it will be same, right?
Same. So
Yeah.
you can start something going towards this side.
Yeah.
You can calculate this result. Let's call it left. You can start from this side. You can calculate this result, right?
Yeah.
For each index in O of
Yeah.
n, right?
Yeah. Yeah.
And when you are at, suppose, like this position, most likely your value will be towards left. You will have this value 2. This value will be 2, 2. So in this particular case, minimum will be 2, 2, which is 2. In this particular case, you had 3 here, which is better, but here you had 1.
Yeah.
So this was not a better choice.
Yeah.
So yeah, 1
Yeah.
O of n scan, O of n scan. You can do one extra scan, but I think that you can do that in this scan too, since you already have everything for that particular index to figure that out. So
Yeah.
in 2 ON scan and with space of extra ON for left and right in array, you can get this done. The implementation would be pretty trivial for this.
Yeah.
Yeah, very simple, intuitive. And then now we can actually go to that other solution which someone suggested. So this makes sense. Anybody has any question on this approach? I brought it up because it is useful in many questions. So it's a good idea to think like that. Like,
Can we do it without using extra space?
yes, yes. So the first solution which was suggested was not using extra space, I think. Is that right? Whoever was Can you come up again?
Sorry, which one?
So the first solution you proposed, sorry, I can't see your name, but that was not using this extra array. Is that true?
No.
Yeah. So what, let me erase it, like some part of it, and then.
So if we're taking extra array, then we're taking all the indexes there where we've seen one.
If we are taking extra array, what was the question? Sorry, I didn't get you.
My question was like, when we're taking extra array, then we're placing all the positions of, we're counting where we have seen one and putting their index.
Yes, we are calculating like towards my left. When did I see one last?
Okay.
And same with right. Towards my right, when did I see right last?
I might have missed that approach without the extra
Yeah.
space. Could someone just,
No,
reiterate that point?
I'm just trying to understand that extra spacing because you mentioned that can be used in other questions as well. Just trying to understand more on that. Like how I can use it to other places. That's what like I'm interested.
So
Oh, you're asking. Sorry,
The
go ahead.
extra space one.
So actually, I think Puneet is asking. He wants to get details about the solution which doesn't use extra space.
No, I'm interested in the one which has
And
extra
you are
space.
and you are on the other approach, right?
Yeah.
Yes.
Because you mentioned like that can be used to other places, so that's what I got interested.
Yeah, I mean, so do you know that approach? Like, is it clear, or we can spend more time? I can
If you
explain
can
it.
spend 1 or 2 minutes, I think that would be fine.
Okay. So again, you know the reason why we are doing that. If you are at ith index, what information is useful for you is who is the closest guy towards my left, right? Same with right. So if we do one scan, we can continue to update that. Hey, one, this value is 0 for I'm trying to create this left array. 0, I know there is one guy towards my left, so I can create 1. For this guy, this will become 2 because from previous value you can add 1. For this 3, now we see 1, then this will become again 0 because this position is already taken. So your counter will start again from here. Again 1, and then again 0. So at this point of time, for each index, we have the information of the left seat. Like
Okay, from left home. Okay.
from left side. You do the exact same thing from right side. How we can do that? Okay. 0, 1,
1, 0.
0, 1, 2, 3, and then 0, right? Now these are your candidates for each I. And this is the best candidate because minimum of this value is 2, minimum of this is 0, minimum of this is 1, 0, 1, 1, 0. So this is your solution.
Minimum and then take maximum. Or
So minimum of left and right. So that's what, right? Clear?
I was thinking, sorry, go ahead.
So it should be minimum.
So minimum among the left and right, and what is the resultant? You have to find the maximum among them.
Yeah. Got it.
Oh yeah, you are talking about overall overall max.
So there will be then 3 arrays.
Yes, max for this overall things. Yeah.
So left to right, right to left, and then the third array.
Yeah.
Or
you can call it array, but while you are doing this R traversal, you can continue updating your max while you are doing this.
Yeah.
So
it makes sense. Yes. Sounds good.
Someone in the start said about the 3 cases. One is where you have starting with 0, ending with 0, and the middle ones.
Yeah, so that's what I was telling. I think so it either so they mentioned like there could be there would be at least already one in the array. And then that means like it could be anywhere, or there could be multiple ones also. So like in this example, we can play somewhere in the in between, but there could be two more cases where we can place at the start or at the end. Then we can take this as a two-pointer approach. When I've seen one for the last time and when I've seen currently one.
Yeah, I think then the problem is actually. Roger, can you mute? There's a lot of background noise.
Yeah, let me.
डेटा लगे लोग आते हैं उस पर थोड़ा चल रहा अभी थोड़ा.
Okay.
Yeah. So I think the problem then reduces to finding the maximum number of zeros on the start, maximum number of zeros in the end, and for anything in between, just have a number of zeros divided by 2.
Something similar, yes. So
because in between you will always find the maximum of two sides will be kind of half, right? If you have 1, 0, 0, 0, and 1, and your maximum of both ends will always be the center point.
Yes. So think in that way, like we have to make something like a previous. So when I see 1 for the first time, that will become my previous.
Yeah, that's the first maximum.
And yeah, that is my first maximum from the start. Then after that, I can have another loop where I can start from previous till end and keep on. If I see next one, then take a half of that. And then at the end, if there is again 0, if at the end, then have to do then again how we did from the start, like from end till I have seen 1 for the previous, then that length could be another candidate.
Yeah, essentially you're finding, counting the number of zeros in between. That's correct.
Okay, so are we talking about the O of 1 solution basically at this point of time?
Space wise, yes, O of 1. Time wise, it's still again O of n.
Yes. Okay, so someone suggested that solution earlier. So we are done with this two-pointer approach, and I will try to refer a problem which is where this will be very useful, just so that it's a good pattern to think about when you are seeing left and right. Sometimes it will make your solution very trivial to implement.
Yeah. And for the approach that we discussed about counting the number of zeros, there's another problem on Leetcode. I'll ping that also. So probably you can look at that approach also.
Great.
Where you have pinged?
All right, guys. So somebody wants to start with the O of 1 space solution, or is it clear? We can go to the O of 1 space because that is the best solution for this one.
Sure.
Okay, so let me erase this part now because this doesn't make sense. Okay. So now, how to do this same thing without creating an array? What we are interested in, and I'm thinking with you at this point of time, it's pretty sure, clear that we need 2 pointers, where first pointer will give me the left side of where I am standing towards left, and right pointer will tell me where I am seeing another guy towards right, approach wise. And then I will continue to traverse using that. So let's call left and right. And in the beginning, I see right, maybe left doesn't mean anything for the boundaries, right? So maybe my left is, let's call it -1. My right is 1. So I definitely can't sit here. Is that right? So then I want to find a position where I can actually sit. Left can be this one, right? I can sit at this position. So towards my right, I can see, okay, where is the next taken seat basically. So I can find this one if I do a traversal from here till here. So my right will be here at this point of time. And I have to keep an account, okay, at this position, towards my left, I have just one position. And towards my right, I have 3 positions. So my current best score is 1. Now this guy can move here. It can update this value to 2, and this value, because now I can have, hey, where is my right index? That can be 2. So I can get, okay, my current best solution is 2. Then the left can come here again. And so left will be 3, right will be 1, and then your best will be again 1. But this is the best. So this is my overall result. When I come here at 1th place, I know this is not a valid position. So ignore this one. So we go here and check the last left position. So again 1, you have to reset the counter also in that particular case. And also check towards right, what is the closest one guy. So again 1 and 1, the value will be 1. Yeah, I think it can be implemented with 2 pointer. You keep going ahead, and every time I find a suitable candidate, I make sure my right is actually towards right of the left pointer, and we can get it done in O of n time and O of 1 space. I think I should be able to send the solution. If someone has already written this code, please suggest it on the channel. Or if it was not clear, let's talk about it for some time. Was that the approach, Puneet, you were talking about?
Similar to the concept, but I was just, instead of finding the next one and trying to place it, I was just counting the number of zeros and dividing by 2.
Oh, yes, that may work too. Yeah, because we only have 0 and 1. Yeah, we can. That may work too. Yes. Okay, sounds good. Anyone has any questions on this approach?
Puneet, your approach counting by 0, counting all 0 places and divided by 2, and how we are proceeding in the array?
What he's saying,
Yeah.
if you counted this value as 3,
Okay, got it.
then 3 by 2 is basically your minimum of 1, minimum of 1. 3 by 2 is 1, right? Are you doing ceiling, by the way, Puneet?
N plus 1 by 2. So it will be 3 plus 1 by 2. That's your maximum distance.
Yeah. So you are doing, okay. Yeah, that makes sense. So it will be 2. Like in this particular case, he can figure it out that the best solution he can get is 2. So that's a smart idea. But conceptually, you can do the traversal using 2 pointers, and then you can figure out the solution in one scan. Can we move to the next question?